To solve question 55, we have 4 terms, so we would probably first try to group and then pull out the GCF of each group. We can pull out an x squared, we're left with x minus 5. We can pull out a 3, and we're left with x plus 3, and very quickly realize that these binomials are not identical, which means we can't factor using grouping. The only other technique we would know is to graph, and hopefully they're all real zeros. If they're not, we would have to use synthetic division to get this down to a quadratic, which would allow us to then find the 2 imaginary. We haven't talked much about this technique, but I think you can pick up on it very quickly. So what we're going to do is we're going to take this, and you can just plug it into your graphing calculator. I'm going to graph this, and I'm going to take a look at the number and types of zeros. Going to work on my 5s. Okay, so here we have this, and when we graph, what it looks like, let's zoom in. What it looks like is that we have 3 real roots. 1 is a double root. Looks like we have it at -1 here, and positive 3 is our double. So what this means is if we know at least one of our zeros, in this case we know them all, but if we know one, we can use synthetic division. Now we're a 3rd degree polynomial function. If -1 is a 0, okay, if -1 is a 0, that means x plus 1 is a factor, okay. This value gives us a y of 0, so it means it's evenly divisible. So we could either divide by x plus 1, or we could use synthetic division with our coefficients of 1, -5, 3, and 9, and our 0 of -1. Bring down the 1, multiply, add, multiply, add, multiply. Okay, and we see here that it is a factor. Y is equal to 0, remainder theorem. And what we're left with, this was x cubed. This is now x squared minus 6x plus 9 equals 0. We found one of the zeros. To find the other 2, we could either use the quadratic formula, or in this case, factor pretty easily. This would be x minus 3. X minus 3, therefore our zeros are 3 and 3, or 3 with the multiplicity of 2. And that is how you would solve question 55 from the Advanced Algebra 2 homework.